All right, everybody, here we go on solving rational equations. Now, we have already talked about simplifying them and multiplying, adding, subtracting, dividing. We've done all sorts of things with solving or with rational equations and functions so far. But now what we're going to do is we're actually going to solve them for the value of x. Now, solving for the most part can be done a couple of different ways, and I'm going to show you my favorite way to do it, and then when we get to some that only have two terms, I'll tell you that you do have options, and so we'll just see what you want to do. So let's just talk about the first example. What I would recommend that you do is find a common denominator for this entire equation. So we have a denominator of x and 2's. So our common denominator is going to end up being 2x. So if it helps you, you can write down that your common denominator is 2x. And now we're going to go find out everything that we need. So this denominator needs a 2. So we're going to multiply 2 to the top and bottom. This one needs an x. So we're going to multiply by x on the top and bottom. And this one again needs a 2. So we're going to multiply the 2 to the top and bottom. And that's going to create a new equation. But the cool part about it is when we're solving, if all of them have the same denominator, we can go ignore the denominator now. So now this just becomes a single function. So we just have 2 times 4 is 8 plus 5 times x is 5x. And that's equal to negative 11 times 2 is a negative 22. And we're just going to go solve for x. So that's going to give us 5x is equal to a negative 30. So x is equal to a negative 6. Now, when you are done, this part is crucial. You must look at your denominator. You must look at the function, because sometimes we can have extraneous solutions, which means there are solutions to the problem, but they don't actually work if we substitute it back in. So negative 6, check to make sure we can divide by negative 6. That's perfect. But sometimes, for example, what if we got x equals 0? We can't divide by 0, so we would not be allowed to use 0 in the denominator. So once we're done checking, we want to write our answers in set notation. So this is negative 6, and we do not write an extraneous solution of nothing. Another tip for you is before you even get started, maybe you want to list your domain. So for the second example, maybe you want to list your domain restrictions and just make a little note that x is not allowed to equal 2 because we cannot divide by 0, and 2 minus 2 would give us 0. But then you can go solve this the exact same way I just showed you. So if you would like, pause this video and give that one a try and see if you can handle it. So if you gave it an attempt, you would notice first you need to get a common denominator of x minus 2 for this part. And after you do that, remember, if they have a common denominator for the whole thing, you can get rid of the denominator and just solve using the numerator. So that would give us 5x is equal to 7 times x minus 2 plus 10. And that would give us 5x is equal to 7x minus 14 plus 10. And now we're just going to continue solving. So that's going to give us a negative 2x is equal to a negative 4. So x is equal to 2. Now I want you to go back and look. We said x is not allowed to be 2. Because our domain is x can be anything except for x cannot equal 2, because if we substitute that back in, we would have a problem in our denominator. So how do we write this? Well, that means we have no solution with an extraneous solution of 2. Okay? So make sure you double check when you are done, or list your domain at the beginning and make sure it matches. Okay, so we said x is not allowed to equal 2, so if we solve and get 2, we're good to go. We're done. Okay, number 3. So number 3, we're going to have to go do a bunch of work as well. Now the first thing that we're going to need to do here is factor and come up with our common denominator. After we do that, we have to do a whole bunch of algebra and see how everything works out. So I'm going to tell you to pause the video again and give it a shot on your own. Okay, so This one should factor to x plus 2 and x minus 2. This guy has nothing, and this guy has an x minus 2. So when we are working with this, we're going to need to give this guy an x plus 2, and give this guy both of them, which would be an x plus 2 and an x minus 2. If you want to do a shortcut and just call it x squared minus 4 so you don't have to remultiply, that's fine as well, just as long as you know what's happening. Now, boom, we can cancel our denominator. And we need to have an equation of 3x minus 2 times x plus 2 is equal to 6 plus our x squared minus 4 times 1, which we obviously don't need to multiply by. Now we're going to have to multiply the left side. And if we were to multiply the left side over here, we would have 3x squared plus 6x minus 2x minus 4 is equal to 6 plus x squared minus 4. And get everything over to the left side, we should have a 2x squared plus 4x minus 6 is equal to 0. And we can factor out a 2, leaving us with x squared plus 2x minus 3 equals 0. And then we're going to factor and have 2 times an x minus 1 and an x plus 3. That's equal to 0 as well. So we have x is equal to 1 and a negative 3. And then we need to go back and check. So remember, at the beginning, another thing to do is you could have listed your domain. X was not allowed to equal 2 or negative 2. In this case, we have 1 and a negative 3, which both work. So that's going to give us our solutions of 1 and a negative 3. And we write that in our solution set, and we are good to go. Now, number 4 and the last question, number 5. I'll give you a sneak peek to number 5. I'm going to show you 2 different ways to do it. And you can choose either one you want, but remember, way back in the day, you learned that whenever you have 2 equations or 2 fractions equal to one another, to solve them, you can simply cross multiply. So if we were to multiply x squared minus 1 times 1, we would get x squared minus x, and that equals 2 times x minus 1, which after you distribute is going to give you x squared minus x is equal to 2x minus 2. And then to solve, we would just bring everything over to one side, and we would get x squared minus 3x plus 2 equals 0, giving us an x minus 2 and an x minus 1. So x is equal to 2 and 1. Now we need to go back and look at our original equation to find out that 1 is an extraneous solution. So we would have to write our set as a solution of 2 with an extraneous solution of 1. Now I want to tell you that the other way to do that would have been to do it the exact same way we did it in the last equation. So we could have factored out an x here and seen that we would have had x times x minus 1. So that means our common denominator is x times x minus 1, so this side would have needed an x. So we would have multiplied this side by an x in the numerator and the denominator, and we would end up with 2 is equal to x. But notice your extraneous solution will not show up if you do it that way, and that's because by finding the common denominator and not multiplying both sides by the same thing, we eliminated that. So if you do it that way and it goes away, as long as I'm following your work, you won't lose points for doing it that way. Okay, so here's our last example. If you would like to pause and give this one a shot, I would encourage you to do so. If you would like to actually just watch, here we go. So again, if we factored out our x here, we would have x times x plus 4, and over here we have an x plus 4. So if you were to cross multiply, we would multiply this by an x plus 4, we would multiply this by an x plus 4. So naturally, when we were done, we would end up with a negative 4 as a solution. So if you cross multiply, you will have negative 4 as an extraneous solution. I'm just giving you a heads up. But if you want to do it this other way, then we would factor out our x here, and our common denominator is going to be x times x plus 4. This side has an x plus 4, so we're just going to multiply this side by the x. And by doing so, again, we're going to end up with 3 is equal to x, and we're done. And x does work, so we're going to write it as a solution. X is equal to 3. Now, like I said, if we would have cross-multiplied, you would have also come up with a negative 4. If you would have cross-multiplied, we would have had x squared plus 4x is equal to 3x plus 12. And after we would have factored and got x plus 4 and x minus 3, we would have a negative 4 and a positive 3. So we would have written our solution still 3, but we'd have an extraneous solution of a negative 4. So again, it doesn't matter to me which way you want to solve it. Just make sure you show very accurate work so I know what's going on. And at the beginning, of course, we would have had, we could not have had a denominator of 0 or a negative 4. So that's how we, can double check. All right, this is Longo and I'm out. See you, bye.